type n times n times 10 to the power of m, n times n to the power of m, where my m can be any integer, m is any integer, but my n, its minimum value, my n's minimum value could be 1. It cannot be less than 1. My n has to be minimum 1 and it's supposed to be less than 10. Note, so what they want in scientific notation is my m can be any integer, so I'm not worried about n. I'm worried about n. I want my n between 1 and 10. N could be any number between 1 and 10. It could be 1 but it cannot be 10. Note, there is no equal sign near 10. So it cannot be 10. It has to be between 1 and 10. But it can be 1 but not 10. That's scientific notation. How do you do that? Let's see. Here. So I'm going to do here 5th. So example, it says you have to write 83,000 in scientific notation. You have to write 83,000 in scientific notation. So what you want is, you have to write something as 10 to the power of some number, and you need some number here. So what you're gonna do is, let's see these first two terms. Let's see this. Okay, how do I explain this thing? Are they writing? Okay, first 83. Okay, so you have this number here. I want you this 83,000. Okay, so see 83 here. Let's see the first two digits here. Always to look at the first two digits. Okay, if I consider these two numbers 83, okay, if I consider these two number 83, I note I want 10 between 1 and 10. N, this my n should be between 1 and 10, right? If I consider the first number 8, that's good. 8 is between 1 and 10. I can choose 8. Perfect. But what about 83? If I choose the first two numbers, that means I cannot have 83. I cannot have 83 because it's not between 1 and 10, but I can have 8. So what I need to know is 8. I put 8 here. So my n is 8. But what will be my m? What will be my m is, so what I'm going to do is, after 8 I'm going to put a decimal. I'm going to put my decimal. So how many numbers do I have after that decimal? 1, 2, 3, 4. So my m becomes 4. I know this is confusing. We'll get with this with more examples. So I'll explain again. So what you do is, start considering the numbers. Like, hey, first let's see the first digit, 8. It is between 1 and 10. Good. I can choose 8. So that means I'm going to put a decimal after 8. How many numbers do I have after decimal? 4. So raise the 10 to the power of 4. So it becomes 8.3 to the times of 10 to the power of 4. That's my scientific notation. You're like, I'm not writing 0. You don't have to write 0 after. Let's do one more example. I'll do more examples on this. So you have 0.0327. I say you have to write this in scientific notation. I need n between 1 and 10. First I consider the first digit, 0. It's not between 1 and 10, so I'm not considering 0. This 0. No. This 3. Yes, this 3 is between 1 and 10. So I know my n is going to be 3. And after that 3, I'm going to put decimal. Whatever is after that, I'm going to put decimal and write it here. Times 10 to the power of something. But what it's going to be? So in this case, your decimal already existed. But you are moving decimal towards this side. And how many times did you move? 2. So it becomes negative 2. Are you getting it or no? Did everyone
Okay,
understand?
so you have to use the 10 and whatever amount or however many exponent counts until the number is between. Okay, so
Yes.
the starting number is between 1 and 10.
Yes.
Yeah, okay.
So when you're moving, basically when you're moving the decimal towards right, this exponent will be positive.
Mhm.
But when you're moving towards left, see in this case you're moving towards, sorry, you can say moving, not left, sorry, left. This is left. Left, if you're moving towards the left, your exponent will be positive. Towards right, if you're moving, your exponent is gonna be negative. See, in this case, my exponent, so 83,000. I had 83,000. I had no exponent. Technically, I had my decimal here. But I want my decimal to reach here, so I'm moving towards left. How many times I reached? 1, 2, 3, 4. So that's why I have 4 positive. Left exponent is positive when I'm moving towards right. In this case, I was moving right. How many times? 2 times. So that's why I have negative. Are you getting my point or no? Okay.
Yes.
Let's see more
Thank you.
examples. We'll see more examples.
So is it 3.27 times 10 to the power negative 2?
Yes.
Okay.
Let's see one more. I will do more examples on this. So, let's see. They have here. Okay. So you have something as d6. Okay. You have this thing. Okay. Can I have Haley? Haley?
Yes, I'm here.
Okay. Can you help me do this? Okay, let's see. First, what's my n? Let's see first my n.
Here, let me write it down really fast. Would it be 3?
3. And after that, I'm going to put decimal, right?
Yes.
So I put 3.6. I don't have to write all those zeros. Then I need 10 to the power of some number, right?
Yes.
Okay. Where is my decimal right now? In here.
Pardon?
Where is in the original question?
Oh,
do you see any decimal?
No.
So I'm going to put at the end decimal. Okay. I need to move my decimal here, right? You said I need to move my decimal here, right?
Correct.
How many times I'm changing my decimals? Let's see. 1, 2, 3,
8,
4, 5, 6, or 7. 7.
7? Oh, okay.
See.
So it'd be 10 to the 7th power?
7 power. Because you're moving towards the left, it's positive. That's why 10 to the power of 7.
Oh, so if you move to the right, does it make the exponent negative?
Negative, yes. See here,
okay,
in this
cool.
case, I was moving towards the right. So that's why it was negative. Are you getting my point here?
Yeah.
Okay. Can I have Savannah? Savannah?
Yeah.
Okay.
Yeah.
You help me with this problem. So you have 0. Okay. You have this problem.
Okay, give me 1 second to write it down. Okay.
So what's my n?
So your M or your N?
N.
N, it's gonna be 8.
Okay. Times 10 to the power of what?
2, 1.
You mean negative.
It'll be negative 8.
Negative 8. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Yes, it's going to be negative 8. Since I'm moving towards the right, it's going to be negative. Perfect. Any doubt with this thing? Anyone? Okay. Next thing is, so you were given the number, you had to write the scientific notation. Next thing what they are saying is convert to decimal notation. So now you are given the scientific notation, you have to consider towards the decimal notation. Example, let's see example. So you are given 7.893 to the power of 10 to the power of 5. 10 to the power of 5. So in this case, so basically in that case you were adding, so basically you were making number like this, right? We said left was positive, right was negative. In this case it becomes opposite. So when you're converting into scientific, it's this thing. When you're converting into decimal, it's the opposite. So if it's a positive, you will move towards your right. If it's negative, you're going to move towards your left. It's the opposite. It's the opposite here. So now this thing is a positive number. 10 to the power of 5 is a positive. So now I need to move my decimal. So I had this number. I need to move 5 times towards my right. 1 time, 2 times, 3 times. You're like, oh, I'm done with numbers. I don't have more numbers. Start putting 0, 1,
Mrs. K,
4.
shouldn't you be moving to the left?
No. It's
Are you sure?
in case of decimal notation, it is opposite. When it's positive, you move towards the right. When it's negative, you move towards the left. When you're when you're converting,
Yeah, you're going to the right. You're going to the right.
Yes, you are going to go towards the right. We have to go towards the right. When it's positive, you go towards the right.
That's because when you go left, then it's a positive. So we're just reversing the whole problem.
Yes, you're reversing the whole problem. Yes.
Okay. I must have read wrong. Thank you.
So basically, it becomes 789300. It's this thing. Any doubt, anyone, with how to do this thing? Let's do one more example. I'll do one more example. Don't worry. Let's do more examples on this. 6. Let's do more example on this. So you have 4.7 to the power of 10 to the power of negative 8. You have now negative 8. Now note you're converting from scientific to decimal. Scientific to decimal. So you are going negative means you are going to move towards the left. I'm going to move 8 towards the left. So I had initially this thing. I need to move 8 towards the left. 1 I moved. I don't have more. So I'm start going to add 0. 2, 3. So let's see. So 1, 2, okay, 3, 4, 5, 6, 7, 8. So it becomes point 1, 2, 3, 4, 5, 6, 7. That's my answer. You move 8 towards the left.
I have a quick question. So for the last one, because it was a positive number after like 10, so our M was 5.
Yeah.
And we went to the right and we moved the decimal behind the numbers. When we're answering that like on a test, so for the last example, our answer would be 789300, and that's it, right?
7.
And that would have been our answer.
No.
So like for this one,
Yeah.
it's
That's
our
your answer. Yes. This is your answer.
Okay, and then for this one, it's we do add the decimal because we're moving it to the left,
Yes.
and we have to put the decimal there. Okay,
Yes.
thank you.
Any doubt, anyone? So this is about scientific notations. So make sure you remember this thing. When scientific to decimal you're doing. Scientific to decimal. Positive, right, negative, left. When you're going from decimal to scientific, if you need to move towards the right, it's gonna be negative, and if it's gonna move towards the left, it's gonna be positive. Your exponent is gonna be positive. So it's the opposite. Okay. Next thing what we're gonna do is polynomials. We are going to polynomials. So section 4.3. Section 4.3 polynomials. So basically polynomials, there are different kind of polynomials. Okay, so there are terms in the polynomials. First of all, there are terms. So we are going to define what are terms. So basically something like 3a to the power of 4, b to the power of 5, this is one term. Okay, other could be a to the power of 6 only. Okay, or just 7 number is one term. Okay, and then you have, suppose 2a to the power of 6 is a term. How do you define terms? Basically, how do you define terms is, so first of all, what's a polynomial? How does a polynomial look like? It is something like an b to the power of n plus an minus 1 b to the power of n minus 1 plus an minus 2 b to the power of n minus 2, so on up to a to the power of 0 b to the power of 0. So basically there are some term plus some other term plus some other term plus some other term and so on. They can go on forever. So example of polynomials I will give you is 2x plus 4. This is a polynomial. Or 3 to the power of this plus t plus 4. This is also a polynomial. Okay. Or you can give just 7 is a polynomial. 4x square is a polynomial. So basically it's some term plus some other term, and whatever is subtracted by addition or a subtraction sign, those are terms. So if in this polynomial I ask you what are the terms, one is 2x and other is 4 in this polynomial. So the two terms are 2x and 4. What about this polynomial? What are the terms? They are separated by addition and subtraction sign. So the terms will be 3t cube, t and 4. These are terms. What about here? There is just one term, 7. What about here? 4x square. Nothing is separated by addition subtraction here. So 4x square is my only term. What if I have one more example like 3 minus t square? I have this thing. What are the terms in this case? I told you they are separated by addition and subtraction sign. One is 3 and one is negative t square. I'm going to take a negative number or negative sign also. Are you getting my point? What are the terms? What does term means? In a polynomial they are separated by addition and subtraction sign. Any doubt with what are terms? So next thing is if you got to know the terms, there are types of polynomials. Types of polynomials. First is monomials. In the bracket you can write only one term. Monomials are polynomials which have only one term. So examples I could give is 4x square, just one term. Nothing is separated by addition or subtraction sign. 9 is another example. Okay, minus 7a to the power of 19b to the power of 5. Everything is multiplying. There is nothing is adding or subtracting. Again, this is a monomial. There is only one term. If there is only one term in the polynomial, that's a monomial. These are special names for polynomials. Next thing is binomials. Only two terms. In binomials, there are only two terms. Example, so you have 2x plus 4. Note there are two terms here. One is 2x and one is 4. There are two because they are separated by a addition sign. There are two terms. So this is a binomial. Let's do one more example. 3a to the power of 5 plus 6bc. This is also a binomial. Why? Two terms. One is this 3a to the power of 5 because they are multiplying, they are not adding. So one term becomes this. Then this is subtracted by a plus sign. So they are the two terms. So the terms separated by addition or subtraction sign are the two terms. Okay. Next, see one more example. minus 9x to the power of 7 minus 6. This is also binomial. Why? One term is this thing, minus 9x to the power of 7. And from this you are subtracting 6. So that means this thing is my second term. So terms are separated by addition or subtraction sign. Anyone has any doubt with monomials and binomials so far?
I just have a question.
Yeah.
Why does 7 work with the polynomials, but not with the
monomial?
No.
7? Oh, you're talking about this thing?
Yeah.
Okay. This thing is, so basically if I write it in this thing, this means 7 minus 7 times a to the power of 19 times b to the power of 5. Right? Are you subtracting anything in this? No, you're multiplying this negative number with this thing, and then you're multiplying this thing with this thing. You're multiplying. You're not adding or subtracting. So this whole thing is one term only. But in this case, what happens? In this case, what's happening? It's 9 minus 9 times x to the power of 7. You're multiplying these two numbers, right? But then you're subtracting 6. You're not adding, you're subtracting 6. So this becomes one term and this becomes the other term. Are you getting my point or no?
Yeah, I was just wondering about the polynomial section on the page.
Oh.
Is 7 the only integer that works?
Yes, that will be monomial then, because just 7, right? Just 7, only one term.
Okay.
Yeah.
That makes
sense. Anyone has any other doubt with monomial, binomials? Then there is trinomials. In trinomials there are 3 terms. In trinomials there are 3 terms. So basically example I can give is 3t cube plus 4t plus 7. See, there are 3 things separated by addition sign. 1, 2, 3. So it becomes trinomial. Similarly, 6 to x7. Then from this you are subtracting 8z to the power of 2. This is your second term. And that you are adding 4. So this is your third term. So it becomes trinomial. Tri means 3. Remember that way. 4x square minus 6x minus half. So from 4x square, they are multiplying each other. So 4 and x square. So this becomes 1. From this you're subtracting 6x. That becomes second. From that you're subtracting half. That becomes third. So that becomes trinomial. That's a trinomial. Okay. Other than that, if you have 4, 5, 6, 7 terms, there is no special name. Only the term with 1 term, 2 terms and 3 terms, you have special names for polynomials. Other than that, you don't have any special name for polynomials. Any doubt? Okay. Next thing what we are going to do is degree. Degree. Okay. We're going to talk about degree. Okay. So what's a degree is? It is basically highest exponent, you can say highest exponent of the variable. Highest exponent of the variable. Highest exponent of the variable. Variables are x, y, z. So in the comma you can write x, y, t, a, b. These are. So the highest exponent. In the question, whatever you see the highest exponent of these things, that is your degree. Example. If you have 8x to the power of 4. Okay. Can I have Martin? Martin? Christina?
I'm here.
Yeah.
Oh, Martin is here?
Yes.
Okay. What's the degree of this thing?
It's a monomial.
No, it's a monomial. Yes, that's correct. What's the degree of this thing?
The what?
Degree.
Four?
Degree is what we just explained this thing. Degree means highest exponent of the variable. What's the highest exponent? What's a variable here? First, you tell me.
Oh, the 8 is the
So first,
1?
no, you tell me what's the variable in this case.
8.
8 is the constant. You know what is 8, right? 8 is a number.
Oh, X.
It's
X. X.
What's the exponent of x?
4.
That's your degree. The degree is the highest exponent of the variable. First figure out what's a variable. Variable are terms you don't know the value. You don't know the value. X, you don't know what is x. You don't know what is y. You don't know what is z or a, b, c, t, p. You don't know what these are. So those are your variables. You have to find the highest degree of that thing. Let's do one more example. So you have 4x cube minus 7x square plus 7 minus 8. I have Christina.
Mm-hmm.
Can you tell me what's the variable in this question?
The variable's x.
Variable is x. Okay, can you tell me what's the degree? So the variable x, what are the different exponents they have?
Oh, it's 3, 2, and 1.
3, 2, and 1. What's the highest one?
3.
So the degree is
3.
Yes. So you figure out what's your variable, see what are the different degrees, and pick up the highest one.
Oh, okay.
So I again repeat. See what's your variable, pick up the figure out what are all the exponents. Figure out what are the exponents. The all exponents are 1, 2, and 3. And the highest one is 3. So my answer is 3.
I have a question.
Yeah.
So if you had another variable in there, would it be the higher of any of those variables? Does it not matter?
We are going to do that.
So
right now we are talking about in
okay.
one variable. Yes. We'll go
Okay.
to 2 variables. Yes. Yeah. Any doubt with this thing? Okay. In this thing, one more example I want to do is important. This thing is important. Note down this one example. This example here. Very important. If I say just a 7 number, I say what's the degree of this thing. If I say what's the degree of this thing, you'll say, oh, you told us to figure out the variables. There is no variable in this case. When there is no variable, then the degree is 0. Degree is 0. When no variable, degree is 0. Reason, you don't have to remember the reason, but for people who want to know what the reason is, so basically there is a variable, but it is raised to power 0. There is a variable technically which is raised to power 0. So there is x technically, but that is raised to power 0. And anything raised to power 0, anything raised, we did this, to 0 except is 1. The value of anything raised to power 0 is 1. So if I have 10 to the power of 0, that does not mean it's 0. It's actually 1. If I have 1000 to the power of 0, it's not 0, it's 1. Anything to the power of 0 is 1. So technically, you don't have to remember this. It's just for people who want to know why the degree is 0. The degree is 0 because the x is raised to power 0 in this case. Anything to the power of 0 is 1. So you can remember, if there is no variable, degree is 0 directly. Any doubt? Okay. Let's do more problems on this. Let's see. Okay. Okay. One more example I'm going to do is 3x plus 5. 3x plus 5. Can I have Eric?
Yes.
Okay, what's the degree of this one?
I'm sorry.
What's the degree of this term?
Or it would just be 1, correct?
It's supposed to be 1, yes. Because there is only one. What's a variable?
I'm sorry?
What's the variable in this one? Variable.
X?
Yeah,
Correct?
and yeah, it is just x. And if it's nothing, there is 1. So degree is 1. Perfect. You got
Okay,
it.
good.
Yeah. Any doubt with degree? Anyone who did not understand what's a degree? Are they asking? Coefficients? No. Okay. Next thing is we are talking about leading coefficients. So let me explain the leading coefficients also. Okay, leading coefficients. Let's talk about leading coefficients. So basically what is a leading coefficient is constant. It is a constant. So you can say it is constant next to the variable with highest exponent. It says a constant next to the variable with highest exponent. Example. Let's do examples. I'll do the same examples we did before. So suppose you had 8x to the power of 4. You were given 8x to the power of 4. Can I have Carlos? So what's the degree of this thing? First, let's see. What's the degree?
4.
4. How many terms are there here in this one, Carlos?
2, right? The 8 and x and over 4.
Are they separated by addition or subtraction?
Wait, what?
You are saying there are 2 terms, right? 8 and x to the power of 4, right?
Yeah.
Are they separated by addition and subtraction?
No.
They are multiplying, right?
Yeah.
So there is just one term.
Okay.
There is just one term. Okay. You are saying degree is 4, right?
Yes.
So it says I need to find leading coefficient. See the definition. It says it is constant next to the variable with highest exponent. Here, what's the variable with the highest exponent?
It's 4.
And what's the constant next to it?
8.
So that's a leading coefficient. Kenya?
Yes.
Okay, can you do this example for me? 4x to the power of 3 minus 7x to the power of 2 plus x minus 8. What's the degree?
4. 3.
3. And what's the leading coefficient?
4.
Yes. Basically, the term which has the highest degree, you have to see the coefficient of that, the constant with that term. In this case, the constant with that term is 4, so your leading coefficient becomes 4. It's not negative 4, okay? I mean, it's dashed there. Example. One more example I'll take. 7. Chanthon.
Can you hear me?
Yeah. What's the degree?
Hi. 1.
No. I told you when it's just a constant, degree is?
Sorry, one more time.
When it's just a constant, what's the degree?
Oh, 0?
Yes, it's 0. It's always 0, just a constant.
Okay.
So what's the leading coefficient?
Okay, I gotcha.
What's the leading coefficient?
7.
Yes, perfect. There is only 7, so that's my leading coefficient. Perfect. Can I have Anthony?
Yeah.
Okay, I have just x. What's my degree of this thing?
X?
Degree.
0.
What's the exponent of, what's a variable here? First you tell me, what's a variable?
The X.
So what's the exponent of that?
1.
So degree is 1. Okay. Let's see leading coefficient.
X. Or is it also 1?
Yeah, it's also 1. What's the constant next to it? If it's nothing, there is technically 1 times something, right?
Yeah.
So the leading coefficient is 1. Perfect. Anyone who did not understand what is leading coefficient? You should understand what is leading coefficient and degree, because you will need that to graph. If you don't understand, you have to figure it out for graphing. What is leading coefficient and degree? Okay. Next thing we're going to talk about is combining like terms. Combining like terms. Again, I'm telling terms are separated by addition and subtraction sign only, not with multiplication and division. So example you're given, example they are saying 2x cube plus 6x cube. 2x cube plus 6x cube. Okay. Joshua Hernandez. Joshua Hernandez. Maria.
Can you hear me?
Yeah. Hi Maria, can you combine these two terms? Are they like terms?
Yes.
They are like terms because they have the same variable with the same exponent.
So it would be 8x to the 6th power?
No. How do you do it is, okay, is there anything common between them?
The x to the
Third. I took out common. What I'm left with inside? From this thing, I took out x to the power of 3. What I'm left with inside?
2 and 6.
2 plus 6, right?
Yeah.
What does it become?
8.
X to the power of
3. X 3.
Yes, x3 only. You take out common. Whatever is common, you take out common. And then add whatever you can.
Okay.
Yasmin.
Yes.
So you are given problem. I'll do one more example. You are given as 5x square plus 7 plus 2x to the power of 4 minus 6x square minus 11 minus 2x to the power of 4. You are given this thing, this whole thing. Okay, 5x square. You have 5x square. Okay, here. Is there any other x square term?
Yes.
Which is?
2 x to the power of 4.
No. Which is the other x square term? First is this x square term. Can you see any other x square term?
Oh yeah, the 6.
Yeah, negative 6x square, right?
Yeah.
What is 5x square negative 6x square?
1.
1?
Negative 1.
Negative 1. Negative 1 what?
X squared.
Yes. X square will remain as it is. You just combine the numbers. Okay. Let's see. Next is constant, right? I have this constant. Is there any other constant?
Negative 11.
Negative 11. Let's combine. What is 7 negative 11?
Negative 4.
Negative 4. Perfect. Next is x to the power of 4. I have here one term. Is there any other x to the power of 4?
Yes, negative 2x to the power of 4.
So what is 2x to the power of 4? Negative 2x to the power of 4?
0.
0 what?
X to the power of 4.
Okay. And then I'm left with, that's it. Done, right? We did all of the terms.
Yeah.
And what is 0x to the power of 4? 0. Anything multiplied by 0 is 0, right?
Yes.
So I don't have to write that term. So I'm left with minus x square minus 4. Did you get it?
Yes.
Okay. Anyone has any doubt with this question? I'm going to do one more problem. You have 7a to the power of 3 minus 5a to the power of 2 plus 9a to the power of 3 plus a square. Reese, she's not here. Okay, Joshua,
Yeah.
no, the other Joshua.
Hernandez?
Yeah.
Yeah, Joshua Ramirez. Yeah.
Yeah.
Okay, can you tell me how to do this?
Yeah, just let me write it down real quick. Okay.
Reese just said that he was here, but it's not letting him unmute. So he just put it in the little chat box.
Okay, I'll check it. So can you tell me how to do this?
Yeah. So you would.
So this term has a3. Is there any
You
other
would-
term with a3? A to the power of 3?
Yeah.
Let's
So you
combine.
would do the add the 7a to the power of 3 and 9a to the power of 3,
What does it
and
become?
you would get 16a to the power of 3.
Yes. Is there any other a square term?
Yeah, just 1a squared.
Okay, so what do I get?
Negative 5a squared, and you would add those, and you would get negative 4a squared.
Yes, perfect. That's it. That's it. You got it. Niza?
Yes, I'm here.
Okay, can you solve this thing? Y to the power of 5 minus 4 times 6y to the power of 3. 8.1 to the power of 5 plus 3.7y to the power of 2. Yes, Niza.
So is that a decimal or is that multiplication?
Decimal.
Decimal?
Yeah.
Okay, so you would first combine 2.3y to the 5th and negative 8.1y to the 5th.
Yes, so what do you get?
Let's see. Will that be negative 10.4?
No. So you are subtracting from 8.1, you have to subtract 2.3.
What was that?
So on your calculator, do this. Write 2.3 minus 8.1.
Okay.
See what do you get.
5.8.
5.9. 5.9 you'll get.
Oh, okay. And then, sorry, it's really hard to see. And then
Wait, 2.3 minus 8.1 is 5.9. That's 5.8.
Oh, it's 5.8?
Yeah.
Oh, I'm sorry. No.
Yeah, I got 5.8.
Yeah, it will be 8. Yes.
And then negative 4. Oh, sorry. And then negative 4.6 y to the 3rd is alone, as well as
yeah, exactly.
Y to this, squared.
Yeah. So they remain as it is. Perfect. Amazing. Okay. The last example I'm gonna do is this one for this combining, and then we'll get a break. So you have 2 by 3 x to the power of 4 minus x to the power of 3 minus 1 by 6 x to the power of 4. Okay, then you have plus 2 by 5 x to the power of 3, and then you have minus 3 over 10 x to the power of 3. You have this thing here. Okay. Can I have Maria?
Is that 1 over 6?
Yeah, it's 1 over 6. Is Maria here?
Yes.
Okay, Maria. Can you help me with this one? How do you do it?
So you take 2/3 x to the 4th minus 1/6 x to the 4th.
Okay.
And then we do negative x to the third
Mm-hmm.
plus 2/5 to x to the third minus 3/10 x to the third.
Now, what's common between these two? X to the power of 4, right?
So it is I don't know how to go. So
So we have to basically do 2, 3 minus 1, 6, right?
yeah,
How do I subtract them? I need to make the common base.
you multiply 3 by 2.
And multiply the top one also by 2, right?
So you get 4/6.
Minus 1/6, which is? Which becomes
3/6.
Yes.
I mean, yeah.
Which is equal to what?
1/2.
1/2. So you got 1/2 x to the power of 4.
4.
Yes. Let's do this one. So you're going to get something x3, right? You're going to get something x3.
Yeah.
Let's see what you'll get. What are the numbers I'm combining?
-1 and then 2/5 and negative 3/10.
Yes. How do I make common base? What's the base here with -1?
1.
Okay. What's the common between 1, 5 and 10?
10.
Okay. So basically I multiply this with 10. I multiply this with 10. What about this 5?
By 2.
By 2 by 2. So it becomes -10/10 plus 4/10 plus -3/10, which is equal to what?
-9.
Yeah, -9/10. That's it. That's the answer. So now you guys have like 5 minutes break till 11:05. Then I'll see you. If you have guys have any doubt with today's lecture, you can ask me questions during this time. And we'll continue after 5 minutes at 11:05.
Professor, could you just move the paper up a little bit so I can see the bottom, please?
Oh, wait. Okay. Wait. Yeah. Oh, I'm sorry.
Thank you.
I didn't know. My chat is open.
I have a question.
Yeah.
So the problem that I did, the one with the decimals,
Yeah.
I'm a little confused because I thought that if there was like a negative or subtraction sign in front of the number, then it was negative.
So, like you're talking about, wait. Some people are noting down. So you're talking about negative 8.1 and 2.3, right?
Yeah.
Negative 8.1 and 2.3. So you're combining both of them, right? One is positive number, so you are saying, so you have negative 8.1 plus 2.3. You had to combine these two, right?
Mm-hmm.
One is negative, one is positive. That means you're going to subtract.
Okay. Oh, okay. Yeah. Sorry. I know what I did. I added for some reason and I made it negative. Okay. Thank you.
Yeah. Perfect. Yeah. Any other doubt, anyone? Everyone got today's lecture so far?
Professor?
Yeah.
Oh, I got your email about the homework and I submitted it this morning.
Yeah, it's okay, no problem. I mean, it is, you still have time to do it. It's due on Wednesday.
Okay. Yeah, no, I'm talking about the previous homework, the one you emailed me about.
Okay. No problem.
Yeah, I submitted it this morning and then I'll do the other one today, the one that's due on Wednesday, so I don't have to do it tomorrow.
Sure, no problem.
Is the homework 4 due today?
Today's homework will be due on next Monday or Wednesday.
No, the homework 4, the one that I was having, the one that I emailed you about.
That's due on Wednesday, I guess.
On Wednesday? Oh, okay, perfect. Thank you.
Yeah. Haley, you're gonna stay after the class, right?
Yes, I am. Yeah, I can.
Yeah. Sure, stay after the class. Have you guys done this before?
I have, yeah.
You mean like online classes?
And not online classes, this
Oh.
addition, subtraction,
Oh, just-
polynomials.
Oh. Yeah.
I probably did it like sophomore year of high
Yeah.
school.
Do you guys remember this, or it's like very new right now?
I mean, I still do get it, but there are some times where I still do need help. But other than that, it's not that hard.
It's I've done it before. It's just you do things a little different than the way that I learned in high school. So sometimes it's a little confusing just because it's being taught a little differently.
You can always show me, you know that, right? You can always tell me this is the way I learned, and I can tell you it's correct or no. You don't always have to go the way I'm teaching. It's the same thing. So if you learned it different way, just let me know, and you can do it that way too. And I can tell you if you can do it or no. Yeah. Because I'm supposed to, this is a revision, but I'm going too much in detail with this chapter. Okay guys, so what I'm gonna start with is addition of polynomials. So it's basically the same thing we were doing, combining like terms. It's the same thing. So if they say you have to add, so addition of two polynomials, addition of two polynomials. So they say you have to add negative 5x to the power of 3 plus 6x negative 1 plus you have to add to this 4x cube plus 3x square plus 2. They say you have to add these two things. Since there is an addition sign in the middle, just open the bracket. Just open the bracket completely. You don't have to change anything. Whatever it is, write it exactly the same way since it's addition. And combine the like terms. X cube term is here, x cube term is here. So minus 5x cube plus 4x cube is basically just negative 1x cube. X term and x term, I don't see any other x term, just 6x, so I'm going to write it the 6x just as it is. Then the constants. One constant is this thing, one constant is this thing. Negative 1 plus 2, which is negative plus 1. And then I see 1x square, but there is no other x square. That's it. Usually when you write your answer in MyLab, they will ask, they specifically want you to write in order. First the highest degree, which is negative x cube. Then after that the square, if there is a square. Then degree 1 and then always a constant. They always want you to write in order. This and this answer is exactly the same. There is not much difference. It's just that you're reordering. You're rewriting it. First I'm writing the highest, After 3, the less degree is 2. So then I wrote the 2 degree, then the 1 degree, and then the 0 degree. Note the constant has a degree 0. That's how you do the addition of polynomials. Next thing is subtraction of polynomials. Subtraction of polynomials. So if I have the same example plus 6x negative 1, but I need to subtract these two polynomials. I need to subtract these two polynomials. So when you are doing the subtraction part, what you have to do is you have to make sure first bracket you can open as it is. Whatever is inside, it remains as it is. But you're going to change the sign of each and every term of the second bracket. When there is subtraction, you have to change the sign of each and every term. Note 4x cube is one term. It is positive 4x cube. I will make it negative 4x cube. This thing is positive 3x square. I will make it negative 3x square. This is positive 2. I will make it negative 2. If it's negative, I will make it positive. If it's positive, I will make it negative. So change sign of each and every term after negative sign. After negative sign, change the sign of each and every term. That's for your notes. Let's see cube now. Cube. Minus 4x cube minus 5x cube. It becomes minus 9x cube. Combine the like terms. Then after cube is x squared. There is just one x squared term. I will write it as it is. X term also there is just one. I'm going to write it as it is. And combine the constants. Negative 1, negative 2 becomes negative 3. If you have any doubt with addition and subtraction, ask right now if you have any problem with addition and subtraction of polynomials. Okay, next thing we're going to go is multiplication. Multiplication of two polynomials. Multiplication of two polynomials. If you are multiplying two monomials, like I say, you are multiplying 5x multiplied by 6x. 5x multiplied by 6x. Note, it's multiplication, so I can directly multiply. Let's multiply the numbers together. First the constants, 6 times 5, which is 30. Now you have x times x. Note we did this. Same base, different exponents, multiplication. You add them. So it becomes 30x to the power of 2. Since it was multiplication, I multiply the constants together. Then I write the variables and multiply same base, different exponents. You add them in multiplication. Let's do one more example. Again I have monomials. I'm multiplying first monomials. You have this thing times negative 4x cube. You are multiplying them. This times this. So first multiply the constants. 7 times negative 4, negative 28. Then you're left with x to the power of 5 times x to the power of 3. Again, same base, different exponents. Same base, different exponents, multiplication. You add the exponents. It becomes 5 plus 3, which is 8. Which is 8. Let's do one more example in this case. One more example is, suppose you're multiplying now a monomial with a binomial. I say multiply this x with this thing. Note you're going to multiply this x with each and every term inside. It's basically distribution. So you get x times x plus 3 times x. Again, same base, different x, multiplication. You add them. It becomes 1 plus 1, which is, and it becomes 3x, which becomes x square plus 3x. Let's do one more part. So you have now 5x times 2x square minus 3x plus 4. Multiply and see. You have to distribute. There's one term, this monomial you're multiplying. So multiply with each and every term. It becomes 5x times 2x square minus 3 times 5x plus 4 times 5x. So you're going to multiply each and every term with 5x. Multiply the numbers. First 5 times 2, 10. Same base, different exponents. You're going to add them. Negative 3 times 5, negative 15. X times x. Same base, different exponents. Add. It becomes x square. 5 times 4, 20, and there is just one x. Any doubt so far? Multiplying monomial with monomial, monomial with binomial or trinomial. Addition, subtraction, multiplication, any doubt? Okay. Next thing is multiplying two polynomials. Multiplying two polynomials. So suppose I say you have to multiply x plus 5 with x plus 4. X plus 5 times x plus 4. What you're gonna do is you decide what you have to keep constant. Which bracket you wanna keep constant. I consider this as 1. I've considered this as one bracket. I'm not gonna touch this thing, will remain constant. I will distribute this thing with inside here. So first I multiply this whole bracket with x, then I'll multiply this whole bracket with distribute. I'm gonna multiply this whole bracket with x plus 4 x with x, and then I'm gonna multiply this x plus 4 with 5. I'm distributing. You decide what you want to keep constant. You can keep this constant and multiply that thing with inside. You'll still get the same answer. Now you know how to distribute the monomial with a binomial. Distribute with each and every term. You get x times x plus 4 times x, and here it becomes 5 times x plus 5 times 4, which is multiplication, different exponents you add, it becomes x square plus 4x plus 5x plus 20. Is there any like terms? X square, there is no term. Oh, with coefficient 1 there is 2 terms. I can combine them. X square, it becomes 9x plus 20. Any doubt with this thing? So this is basically multiplication of two polynomials. Next thing what we're going to do is...
So is this also the FOIL method, or is this different?
Yes. So in this case you can use FOIL method. FOIL method you can only use... FOIL method also you can only use when you're multiplying two binomials. When you're multiplying two binomials, you cannot use FOIL method in other cases. If I say something like 5x square plus 3x plus 5, and I say multiplied with x plus 4, in this case FOIL method won't work. In this case you have to keep this constant and multiply with each and every term. I mean, you can do it. FOIL method is not correct. If you understand FOIL method, do it FOIL method. I'm not saying it's wrong, it's correct. But if you do it this way, it's just that all questions work that way. You can do each and every problem that way. Any doubt, anyone? So this thing is important here next I'm writing. Again, this thing we'll be using a lot in this textbook, a lot. So remember these. It says multiplying sum and differences of two terms. Multiplying sum and differences of two terms. So first you have a plus b. You have two terms, a plus b. Okay, you're adding those two terms, and you want to multiply this thing with the same term a but the negative of b. So the terms are the same. Terms are exactly the same, but you're changing the sign of one term. So you are multiplying, you want to multiply a plus b times a minus b. When you have something like this, there is a direct formula. Rather than doing, or you're going to keep this constant, multiply or use FOIL method, or you're going to use FOIL method, there is a direct formula to this, which is a square minus b square. That's a direct formula. So whatever is your a, square that from minus, whatever is your b, square that. Example. So you have x plus 4 minus x minus 4. X plus 4, x minus 4. You have this thing. Note a plus b, a minus b. Your a in this case is x, your b is 4. So write here x square minus 4 square, which is x square minus 16. Note, I am not negative. My b is not negative. I am just squaring the 4, not the negative sign. My negative will remain as it is. If this is not clear, you write it like this. X square, when you are replacing the value in ab and a square minus b square, write it in a bracket so you don't get confused. It becomes x square minus 16. Don't square the negative sign. Don't start squaring the negative sign. That will be wrong. This negative remains as it is. You're just squaring the 4. This is how you use the direct formula. Example, I take one more example. You have 5 plus 2w, 5 minus 2w. Dylan Robert. Dylan Robert is not here. Joshua Jess.
Yeah.
Okay. Can you tell me how to do this one? What does it become?
Would it be 25?
Yeah.
And then would it just be 25? Because you would have negative 4w squared.
Yes.
Or.
Yep, that's it. That's it. Yeah, you square the b. Your b is 2w, so square it. 2 square means 4 and w means w square. You're correct. Any doubt with this thing? Let's do one more example. 3a to the power of 4 minus 5. 3a to the power of 4 plus 5. Brian?
Okay, let me start to write it out. So 3a to the power is 5 times 3a to the power of 5. Okay, so it'd be 9a to the 8th minus 25.
Perfect. Anyone who did not understand how to do this? Next thing I'm gonna do is, there's 2 more formulas. There's 2 more important formulas here. So the square of a binomial. The square of a binomial. So if you have something like, you have to remember those 3 formulas, the 3 formulas I'm giving you right now. One formula I already gave you. The two formulas I'm writing, these three formulas are very important. Throughout this course, you'll be using these formulas. Okay, so if you have something like a plus b whole square, if you have something like this, you cannot say, oh, it is equal to a square plus b square. I distributed the exponent and that's the answer. No, you are wrong. You are wrong. In multiplication, you can distribute and you are done. But in case of addition and in case of subtraction, you just don't distribute. You just don't distribute. But there is something known as you have to add. So a square plus b square, but there is something extra term, 2ab. 2 times a times b. You have to add this thing. In case of a plus b whole square, whatever is a, you square that thing. Whatever is b, you square that thing. But then you have to, with 2, you have to multiply a and b also, and you have to add that term also. And in case of subtraction, it's the same thing. A square plus b square. Even if it's minus, it's still b square. But here it will be negative 2ab. You subtract minus 2ab. In plus sign, you add 2ab. In minus, you subtract 2ab. That's the only difference. Example, let's do an example. So you have x plus 7 whole square. We have to use this formula. My x is my a and 7 is my b. So it becomes x square plus 7 square is 49. Note, I am not done. There will be 2 times x plus a plus b. And then you have to solve. It becomes plus 49 plus 14x. And rearrange. First the highest one, then after the lower one, and then the lowest power one. Similarly is the negative one. Let's do t minus 5 square. It is again formula. A square, a is t, so that becomes t square plus b square. Note my b is 5, not negative 5. Negative is just telling me to use this formula. Negative is just telling me to use this formula. It's not telling me to use negative b. It's just telling me to use this formula rather than using this formula here. So I'm going to use this formula here. So my b is only 5. It becomes 5 square minus 2 a is t and b is just 5. Again I repeat, my b is 5, not negative 5. This negative sign is just telling me which formula to use. That's it. So it becomes t square plus 25 minus 10t. Julian? Julian?
Yes.
Okay, can you tell me how do you do this problem? 3a plus 0.4 squared.
So it would be 3a squared.
Whole square or just 3a square?
I'm sorry, would it be, it would be 3a squared, no?
Yeah, whole square, right?
Yes.
Yeah, okay. Then?
And then 0.4
square?
whole squared.
Okay, then?
And then we would do, it would be 3a squared.
Which is?
6a.
No, 3 square. You have to square both of them. What is 3 square?
6.
Let's use the calculator. Use the calculator.
Oh, 3 squared is 9, I'm sorry.
Yeah, 9. Okay, so it becomes 9 what?
9a squared.
Okay. Plus?
Plus 0.4 squared.
Which is?
1 second, let me put in the calculator. .16.
0.16. That's your answer, Julian?
Yes.
Does it match this formula?
Oh, this is great.
Julian.
Don't you have to add double?
Yes.
As well?
Julian, see here, you did not match the formula here. When it's addition, you just don't distribute. You have to add this extra term here. 2 times A times B. So you have to add here 2 times A times 0.4. Julian, what do you get when you do it?
You get
2.4A.
2.4A.
But did you understand why you were wrong? You did not add this term. Did you get that?
Yes, because you have to do the 2 and times the A and the B.
Yes. Only when there is addition and subtraction inside, you have to add these two terms. When it's addition, you have to add 2AB. When it's subtraction, you have to subtract 2AB.
Okay.
Yeah. Any doubt, anyone? So far? Note, I'm again saying this B, when you are considering this B, I'm not taking the negative sign with it. Note, in this case, there was -5, right? I'm not taking -5. I'm just taking 5. Negative is just telling me to use this formula. Negative sign is just telling me which formula I'm supposed to use. This formula or this formula. It's not telling me that my B becomes -5. My B is still 5. Okay? If you use -5, your answer will be wrong. So make sure this negative sign just tells you which formula to use. Let's see, next thing I'm gonna. Let's see one more example. I'm going to say multiply example. I'm going to take for multiplication. Multiplication. I say you have to multiply P plus 5 times W and 2P plus -3W. You have to multiply these two things. Cat?
Yeah.
Can you multiply and tell me what you're getting?
Yeah, give me 1 second. I'm just writing it down.
Yeah. Everyone do this problem and I want you to tell me the answer for this one.
I would use the
foil.
It would be 2P times 5W times P.
2P. What you're saying? 2P times?
Times 5W times P.
Wait. I didn't get it. What did you say?
2P times 5W times P.
No. So let's see how you do it is. See, take the first term. Take first term from this bracket, okay? Multiply with each and every term of the second bracket. What do you get? What is P times 2P?
2P squared.
Then again take the first term and multiply with the second term. What do you get?
-3WP. I don't know.
Yes, perfect. Yeah, you're correct. You're doing it correct. Done with all the terms. Now let's take the second term. Let's multiply the second term with the first term here. What do you get?
2P or 5W 2P.
Which is? So you can multiply the numbers, right?
10 WP.
Yes. And what about this thing with the last one?
-15 W squared.
Yes, perfect. Can I combine anything?
Yes, you can.
Which one?
-3W or WP
and 10 WP
plus 10 WP,
which is
7 WP.
And then you have -15 W squared. Perfect. WP or PW, it means the same thing. Multiplication, you multiply 2 with 1 or 1 with 2, it still gives you the same answer. So don't get confused if I write WP or PW, it's the same thing. You have to combine them. Next thing is division. So we did addition, subtraction, multiplication. Next thing is division of polynomials. Division of polynomials. Yeah, now you're going to divide. So if I say x to the power 4 plus 15x to the power of 3 minus 6x squared by 3x. By 3x. If you are dividing a polynomial by just one term 3x, it's very easy. When you are dividing with just one term 3x, divide each and every term with 3x. When you are dividing with a monomial, it's very easy. Dividing a polynomial with a monomial, it's very easy. So you have x4 plus 15x cubed minus 6x squared. And you have to divide by 3x, right? Divide each and every term with 3x. Divide each and every term with 3x. Dylan Robert. Not there. Anthony. And
yeah.
Can you tell me what is x to the power of 4 divided by 3x?
Negative.
See, division, same basis, different exponents. What do you do?
1 over 3.
Yeah, 1 over 3. But division, what do you do with exponents when division? So you have same variable, right? X, different exponents, and you're dividing. What do?
You make it -4 or no?
You in case of division, you subtract the exponents. In case of multiplication, you add the exponents. So you have x to the power of 4 divided by x to the power of 1. What does it become?
5.
Do it?
I said 5.
Subtract. Division means subtraction.
3.
Yes. So let's do here. What is 15 divided by 3?
5.
Okay. Now again, same variable, different exponents.
And then it will be over 2 or power 2.
Power 2. Okay. Now again, negative 6 divided by 3.
2x to the power 1, so yeah, just 2x.
Yes, perfect. Sorry. Anyone has any doubt with division? When you're dividing with the monomial, just one term, just divide each and every term with that and simplify. That's like the easiest way of dividing.
Can we do one more?
Yeah, let's do one more on this one. Let's see, you have 10 a to the power of 5 b to the power of 4 minus 2a cube b square plus 6a square b. You have to divide this whole thing by negative 2a square b. Divide this into negative 2a square b. Now again, this is only one term. It's only one term because everything is multiplying each other. I'm not adding or subtracting anything. So what I'll do is I'll divide each and every term here. This is one term, this is one term, this is one term, because they are subtracted by addition and subtraction. I'm going to divide each and every term with that thing. So it becomes this thing divided by negative 2a square b. Then you have negative 2a cube b square, then divided by negative 2a square b. Then you have 6a square b divided by negative 2a square b. You got this thing. Now you have to do it. Let's do it. So How do you do it? So can I have, let's see, Rockwell,
Yes.
can you do this? What does it become?
It becomes 10. No, not 10. Negative 5a to the third power and b.
B. Okay. What does this become?
Minus 8.
What is minus 2 divided by minus 2?
Oh yeah, minus negative. Oh no. Well, yeah, it's just. Oh, okay, no, yeah. Plus a times b.
Plus 8 times b. Perfect, because, okay. What about this one?
That one. Well, it's just going to be b minus 2a squared.
Here you are saying it is
b minus b minus 2a squared.
It is 6. This is 6. This is 6.
Yeah, in parentheses, yeah.
What is
right?
6?
Oh, that's a 6?
That's a 6.
Alright. Okay, that's a 6, then yeah, that changes it. So yeah, 4a squared.
4?
Yeah.
What is 6 divided by negative 2?
Oh, okay. I thought you were supposed to. Okay. Negative 3a squared.
What is a squared divided by a squared?
We're divided by?
Yeah.
Isn't it? A squared divided by a squared isn't it 0? Because you're subtracting since you're dividing?
Yeah, so it becomes a to the power of 0, b to the power of 0, and anything to the power of 0 is 1.
Okay, it's a to the power of 0.
And anything to the power of 0 is equal to 1.
1.
So basically you get negative 3. Any doubts so far with division?
I have a quick question.
Yeah.
How would you know what to divide by?
In this case?
Like in both problems you divided by different things?
Yeah, see it says by. You have to divide by this thing.
In every problem?
Yeah, it will say by. Divide by what thing? So in this question it says divide this thing by this thing. So I divided the whole problem with this thing. In this case it says this divided by this. This means divide by. Sign. Divide by this thing. So I divided by that term. Did you get it? Okay. Next thing is 14. When you are dividing, the last thing we'll be doing for today is dividing two polynomials. So note, in previous examples we were dividing by a monomial. Monomial means there was only one term. You were dividing by only one term. Now in this case you will divide by more than one term. So if I say divide 2x square plus 5x negative 1 by 2x negative 1. They say you have to divide by this thing. In this case you will do the normal division method. So whatever you have to divide, you will write that inside, and whatever they are asking you to divide by, you're going to write it outside. But before doing this, one thing, make sure they are in standard form. Standard form means first the highest degree, then the lower degree, and then the lowest degree. So the highest one is highest exponent. Variable of highest exponent is 2. First the 2, then the 1, and then the constant has 0. Here also highest one first and then the lower one. So you have to put in the standard form if they are not in the standard form. I again repeat, you have to put in the standard form. The highest one and then lower, 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 lower. You keep on going lower. Okay. Here now.
Where did you
I'm sorry, where did you get the 2x minus 1?
Here, see, divide by.
But like, so when we're doing this on the homework, is the homework going to tell us what to divide it by?
Yes. Yes.
Oh, okay, okay.
The question will look like this. The question will look like this. Yeah. So how you're going to do it is, how do you do this thing is, look at this first term and look at this first term. That's why I say you have to put in standard form. Look at the first terms. This has 2x, this has 2x square. This has 2x square. So what does x square means? Basically you're multiplying x twice. So this has 2x square and this has 2x. Divide them. Divide them. Divide this 2x square with the first term of this thing. What do you get when you divide it? Basically this 2 gets cancelled. This x gets cancelled. You are left with just x. So write x on the top. So first step will be, take the first term of the quotient and the first term of the dividend. This inside is known as dividend, this thing is known as quotient. Take the first terms. From the inside one, divide the outside one. Whatever you get, write it on the top. Next thing what you're going to do is multiply this, whatever you wrote on the top, with everything here. So multiply this x with 2x minus 1. What do you get? Distribute 2x square minus x. You get this thing when you distribute. So after you did that, you're going to multiply this x with this whole thing. Once you multiply, you got this. Write the x square term underneath the x square term, x term underneath the x term. So you get 2x square minus x. You get this thing. Subtract them. Either you remember to subtract them, or what you can do is change the terms, signs of each and every term. This was positive, make it negative. This was negative, make it positive. Change the sign of each and every term. Now simplify. 2x squared, negative 2x squared. They will get cancelled. If they are not getting cancelled, that means your answer is wrong. One will be positive and exactly the same will be negative. When it was 2x squared, this is also 2x squared. One is positive, one is negative. They get cancelled.
I have a quick question. So when you're dividing, so that first, the coefficient and the variable, so 2x squared, you're dividing that by both 2x and negative 1, right?
Just 2x. Just 2x.
Just the 2x. So the one is just kind of like, it just kind of transfers over, or the one just doesn't, we're not using that right now.
One is not there while you are finding what to write on the top. But when you are multiplying, then you have to multiply with negative 1.
Got it. So you find like how 2x goes into 2x squared, which you put the x on top, and then from there you multiply your answer by negative 1?
Both of them.
Got it.
By both of them. And whatever I got, I write it here.
Okay.
And then change the sign.
Got it. Okay.
So what if 5x plus x? I get 6x. And then I get the next term down. Once I'm done with this step, I again need to see the first term here and first term here. From the inner one, divide the outer one and see what do you get. X and x get cancelled. 6 divided by 2, you get 3. Write positive 3 on the top. Note you're just dividing the first terms. Once you divide the first terms, you're going to multiply this positive 3 with both the terms here. So 3 times 2x is 6x. And 3 times negative 1 is negative 3. Note you have to change the signs also. This was positive, this became negative. This was negative, this became positive. Then cancel. These will cancel. This will always cancel. One will be positive, one will be negative. Always cancel. And then you get answer as 2. There is no other term to get down. So that's your answer.
We do another one of those?
Yeah.
Wait, the answer is x plus 3 or is it 2?
I'm going to tell you how to write it. So this thing is known as quotient. What you write inside is known as dividend. This is known as divisor, and this is known as remainder. Oh, sorry. I'm sorry. This is divisor. I'm sorry. I wrote it wrong. This is quotient. I'm sorry. That's quotient. That's divisor. So your answer will always be quotient plus remainder divided by divisor. That will always be answer. So final answer will be, what's your quotient? Quotient you found is x plus 3. Whatever is written on the top plus whatever answer you found here, 2 divided by 2x minus 1. That's how you write your final answer.
Professor, could you explain this next example that we do just a little bit slower so we can kind of see the steps better? Thank you.
Professor, just one quick question. When you flip the sign, so like when you got 6x or when you got negative 2x squared plus x, is that because you're subtracting the negative, so you just made it a positive?
Yes. So basically what you're doing is you have to subtract this from this. When you're subtracting, basically you're changing the signs of each and every term.
Got it.
Yeah.
And the way you got it was because that was the first thing that multiplied 2x and went into 6x?
Yes.
You didn't work out the negative 1. You just try to get the first.
You can see the chat.
Yeah.
Okay, got it.
Maybe I'll do the next problem really slow so that you guys can get it. I'll do it very slow. 15. Let's do one more example.
Wait, I didn't get to write down the answer.
Oh, you did not get to write down the answer. If you guys ever, you know what you miss this notes or anything, I upload these notes on Canvas. I upload my lecture and notes on Canvas, so you can always note it from there in case you miss it ever. Okay. Next problem I'm gonna do is x cube plus 1 divided by x plus 1. Yes, x cube plus 1 divided by x plus 1. Note, is it in standard form? Okay, first come x cube term. Do I have x squared term there? After x cube comes x squared. There is no x squared. So I'm going to add myself 0x squared. Then after x square comes x. There is no x. So I'm going to add myself x term. Then there is a constant. So I keep constant is already there. So I put constant as it is. And then you have divided by x degree is 1 and then 1 is 0. So that's in standard form. If it's not in standard form, you write it in standard form yourself. First should be the highest one. Highest is 3. Then it should be square term. There was no square term. So I added myself 0 times square term. After square comes degree 1. 0 times degree 1 term I added myself. It did not add it. And then the 1 constant.
Where did you get like any of the first part? Are you trying to break it down?
No, I'm not breaking. You will need these things when you're simplifying. You will need these things. So when
I was just if it was part of the equation from the original. So is that like the more simplified version or
more simplified version? Yes.
Okay.
I mean, technically, you don't have to write these terms because that does not make sense. This is 0. 0 times x square is 0. 0 times x is 0. You don't have to write those things. But when you're doing division, you have to write it because you'll see why I'm saying. You'll see in the question when I'm doing it. Always first the highest, then degree 1 less. If its highest degree is 3, then take the exponent 1 less, then 1 less, and then the constant. So you always do it like this. Now let's write it in the division form. So you get x cubed, 0x squared, 0x plus 1, and let's divide it by x plus 1. Okay. Now let's divide the first and the first terms. Divide the first and the first terms. The first term here inside, pick up that term, x cubed. Divide that with the first term of the divisor. Pick up the first part of the dividend and then pick up the first part of the divisor. Divide them. X cubed divided by x. X cubed divided by x. Joshua Desiree. Is Joshua here?
Yeah,
Okay.
yeah.
Can you tell me how to do this? What is x cubed divided by x?
I'm like not the best at this, but I would think it would be x squared.
Yes, you're correct. You're
Right.
absolutely correct. X squared.
Okay.
Division, you subtract the exponents.
Okay.
Yeah, correct. So you divide them. Once you got the division, what you're gonna do is, once you found this top one, what you found the top one, you're gonna multiply this with whole of this, whole of your divisor. Multiply this x squared with whole of this x plus 1. Multiply, distribute x, you get x squared times x plus x squared times 1. Multiplication, same base, different exponents, you add, and here you just get x. Once you got this, you're gonna write x cube term underneath the x cube term, x term underneath the x term. X cube I'm gonna write underneath the x cube term, x term I'm gonna write underneath the x term. Any doubt till this step? Anyone?
I have a question. When you multiplied x squared times 1, how did you just get x?
Oh, it's x squared. Sorry, yes, I'm sorry. It's supposed to be x squared. Yes, not x. Anyone who did not understand this part?
Professor, I have a question.
Yeah.
I was wondering if it's possible to simplify and get the answer just by dividing x, and maybe I'm not understanding this right. It could just be me. X cubed plus 1 divided by x plus 1. Wouldn't you get the same answer just doing that with the equation that we're doing right now?
No.
Does that make sense?
You cannot cancel that. No.
Okay.
Yeah. In case of you're saying you're doing like this, right? You're like, oh, I cancelled 1, I cancelled this, it became x squared. My answer. You cannot do that. You cannot do that. You can only cancel when it's multiplying and dividing. In case of addition subtraction, you cannot. Are you getting my, you have something like x cubed plus 1, right? This, in this thing you are adding 1, right? And then here also in x you are adding 1. You cannot cancel. But if I had something like this, x cubed times 2 and I had x plus 8, I'm multiplying. If I'm multiplying, then I can cancel. In case of multiplication, I can cancel, but not in case of addition and subtraction. Okay? My answer is still not done. My answer is still not done. Once you did this, what you're going to do is you're going to change the sign. Your next step is to change the sign. This was positive, make it negative. This was positive, make it negative. And then simplify. X cube, positive x cube, negative x cube. 1 is positive, 1 is negative. They cancel. And what is 0x square minus x square? From 0x square you are subtracting x square. You are left with negative x square. And let's get the next term down, which is 0x. Again,
Are there any other ways to do this problem? I'm just like wondering if there's like a different way of doing it as well. Just because this is like super confusing to me. I don't know. I remember doing this in high school, but I think we learned a simpler way to do it. So I'm like getting really confused right now.
I feel for this thing, I mean, for monomial, dividing with the monomial is easy, but I don't think so there is any other way of doing this.
I mean, if it, let's, for example, so we're doing x plus 1 into x power of 3 plus 1.
Mm-hmm.
So if that's like, if we were to not do that and like do it out in the 0x2 and we just left it as is, like, wouldn't you just realize, oh, x plus 1 going into x3 plus 1, then you put x above and then it's x2, kind of like subtraction when you're dividing it, right?
Yeah, exactly, yes.
So, like, isn't it kind of just like subtracting in a sense without having to do the whole multiplication of it all?
But then what are you going to write? How do you know what you're going to write here?
Well, I'm just like confused right now. Like, it's just
I
very.
know there is a lot of steps, but I mean, that's how. So, basically, what you can do is step 1, if you want to write each part, you can, if you want to write in stepwise is, so first you remember this is dividend. What you write inside is dividend, and this is divisor. Divide first term of dividend with first term of divisor. If you want to write it this way, I mean, it will give you step by step, and you're always doing the same thing till the time you reach the last term. Whatever you get, simplify, and you can say write the answer in the quotient. Quotient is basically here on the top. You're going to write it on the top. And step 3 will be whatever answer you got in step 2, multiply with whole divisor. Step 4 will be write the answer under respective terms and change sign. Step 5, simplify and repeat. Simplify and repeat. These are the steps. These are the 5 steps you are always doing in the same problem. You are doing these same 5 steps all the time.
You screw the paper up a little bit?
Yeah.
Is that all? Okay, that's it. Okay. To where like we can see like all the steps.
Oh, all the steps?
Sorry,
Okay.
yeah, sorry.
So you always divide the first terms of the dividend with the first term of the divisor. Whatever answer you get, you're going to write in your quotient. Whatever answer you get, you're going to multiply with the whole divisor. Then write it underneath the respective terms. Change the signs and simplify. And you're repeating the step again and again.
What does step 4 say?
Write the answer under respective terms. Respective terms and change sign. Simplify and repeat. I'll just do this problem and then you guys can go. I know it's already like I'm up, but yeah. I just want to do this problem. So I'm done with chapter 4. So you have x plus 1 divided by x cubed plus 0x squared plus 0x plus 1. Okay, you have to divide this. Okay, step 1. Divide the first term of the dividend with the first term of the divisor. My dividend is this thing, divisor is this thing. Divide them. X cubed divided by x. I did it. It says simplify and write the answer in the quotient. I simplify this. What is x cubed divided by x? Which is basically same base, different exponents. You subtract, division. You get x squared. Write it in your answer there, x squared. I wrote x squared. Quotient. I'm done with step 2. Step 3. Whatever answer you got in step 2, I got my answer in step 2 as x squared. I'm going to multiply this thing with the whole of the divisor. This whole thing. I'm going to multiply. So you get x squared, x plus 1. Multiply. Distribute. You get x squared times x plus 1 times x squared. Same base, multiplication, you add the exponents. Here it becomes x squared. Once I multiply, it says write the answer under respective terms. So write by respective terms they mean. By respective terms they mean they want you to write x cube term underneath x cube term, x term underneath x term. So write x cube term underneath the x cube term, x square term underneath the x square term.
Okay.
Yeah.
Oh, actually, never mind.
Yeah. And then they say change the sign. Change the sign. This was positive, this becomes negative. This was positive, this becomes negative. And then solve. X cube minus x cube, which becomes 0x cube, so they cancel. One is positive, one is negative, it cancels. From 0x squared, you are subtracting x squared. I'm still going to get negative x squared. Get the next term down. And then repeat the steps again. Take the first term here and take the first term here. Subdivide. So you have negative x squared divided by x. So you get negative. Same base, different exponents. Division. You subtract. You get negative x. Right here, negative x. It says whatever answer you got in your step 2, you have to multiply with the whole divisor. I got negative x as my step 2 answer. I got negative x as my step 2 answer. I'm going to multiply this negative x with the whole x plus 1. Let's see, what do you get? Negative x squared, negative x. Right underneath the respective terms. Change the sign. They cancel. 0x plus x is x, and then you get 1. Again, divide the first term with the first term. X with x. You get just 1. So write here positive 1. Whatever answer you got in the second one, multiply that thing with the whole thing. 1 times x plus 1. It's still going to give me x plus 1. The same thing. I write it here. Change the sign. Positive, negative. They cancel, you're left with 0. If you get your remainder as 0, your answer is just this thing. Quotient. If you're getting your remainder as 0, your quotient is the only answer. Otherwise, you're going to write it in this form. Quotient. Whatever is on the top, you write it there. Plus remainder divided by the x plus 1. But in case it's 0, you don't have to write because 0 divided by anything is 0.
Quick question. So our answer, so the remainder is 0, and then our quotient becomes x squared minus x plus 1.
Yes,
so when we're writing the answer for a test or for the homework, should we write it as how you wrote it down at the bottom as x squared minus 1 plus
circle 1.
Wait, plus, oh my god, there's so many, sorry. Okay, that's the answer that we write?
Yes.
Okay, thank you so much.
Do you mind if we go over this like in the next class?
Yes, we'll go over this in the next class. Yes.
Like if we could spend like a good 20 minutes on it, just because there's a lot of steps to it.
The
Just
thing
make
is,
sure.
I'm not supposed to these problems with you. 4th, 5th, 6th chapter till 6th chapter, I'm supposed to just rush because you are supposed to be, it's revision for you. After 6th chapter is the basic syllabus that starts. Today I was supposed to finish with 6th chapter and you're supposed to have the test of chapter 6 on, till chapter 6 on Wednesday. But I today just finished chapter 4.
But if we're rushing through everything and no one's understanding it, then how is that effective? Like, if a lot of people are confused, how would that be
If
helpful?
you guys have doubt, I'm always ready to stay after class. I always come before class. I'm always here like 20 minutes before. I'm always here after. I can stay right now for you for 30 minutes, 40 minutes. I don't mind, but yeah, I would like you to stay and do it. But next class, I would like to finish chapter 5 and 6. I'm too behind the syllabus. I won't be able to start the actual syllabus. I will be just doing the revision part with you guys. I mean, I'm there to help, but you can come just a little bit early or stay right now after the class. Okay. I have everyone's attendance. I'm just going to take the name of the students and whose attendance I don't have. Dylan Robert. Is he here? Dylan Robert? Gerardo?
Yeah, I'm here.
Rado, you were not there in the initial class. You joined late today.
I joined. It's just my mic was messing up. I was here the whole time though.
Okay. Rado is there. Caesar?
Caesar, I'm here. I just I emailed you because I had the that out early.
It's okay. Richie?
So.
Richie? It's okay, Caesar. Richie? Richie is not here. Okay, and then Reese? Reese is not here. Well,
No, Reese is here. His microphone's just broken.
okay.
But he's been commenting this whole time.
Okay, I'll check that. Joshua Hernandez? Joshua Hernandez?
Here.
Okay, where is Joshua Hernandez? Okay. Okay, perfect. Thanks guys. If you want to stay, if you did not understand anything in today's lecture, stay back. I'm going to explain. Thanks guys. And you don't have the test on Wednesday. You don't have any test on Wednesday. You'll be having next week according to the syllabus. The test is on Wednesday, but you don't have it. I haven't finished the syllabus as yet.
And homework is due tomorrow at 12?
The homework is due on Wednesday. On Wednesday. But today's homework will be due on Monday. Next Monday.
Oh, on Monday, okay.
Yeah.
Thank you.
Yeah, you're welcome. If you guys have doubts, stay back. I'll help you. If you did not understand this division, I can do it with you guys. Just stay back.
Professor?
Yeah.
Just to make sure, you said you're gonna upload the lecture to Canvas?
Yes, I
right?
upload the notes and I upload my video on Canvas.
Okay, awesome. Thank you.
Yep, you're welcome, Caesar. Anyone else? Any doubts?
I was just hoping to ask you a question on the homework that I didn't get to ask in the beginning of the class.
Okay, just a second. Yes. So what's the question? Wait, anyone has any other except like work? Any other doubts?
Can you just give me one more question for the division one? I'm gonna just try and work one out right now.
Okay, I'll give you. You can try it. You can try 9a square plus a cube minus 5 divided by a square minus 1. Okay, anyone else? Any doubt? Okay, Kat, you tell me what is it.
Okay, so it gave me a point which was 4,7,
Mm-hmm.
and it asked me to write an equation of the line containing the given point, and that's what I wrote. I took a picture of it
and
I solved it, and I thought I got it right, but the answer didn't explain it at
No, can
all.
you, it must be saying parallel to a line, perpendicular to a line. It must be saying that wording. It gives this point, but in the question it must be definitely saying parallel to a line or perpendicular to a line, and an equation must be given to you. Can I know that equation?
Yeah, I think so. Okay, so can we solve it out?
Yes.
It's x plus 5y equals 8.
Okay, and parallel or perpendicular?
I didn't get a chance to get the whole question down.
Okay, so I'll tell you the different examples. Okay, parallel and perpendicular, I tell you the both cases, what you're gonna do. Okay, first of all, what you need to know is the slope of this line. You have to figure out the slope of this line. How do you find the slope? Either you go in the slope intercept form, which is you keep y on one side, everything else on the other side, right? If I write it in this form, y is equal to mx plus b, I keep y on one side, take everything else on the other side. I know whatever is next to m is my slope. Whatever is next to m is my slope. So let's see here. I need y on one side. So I subtract x here first. I get 5y is equal to negative x plus 8, right? Then 5 is multiplying. I divide by 5. I get y is equal to negative x over 5 plus 8 over 5. What's my slope in this case?
1 over 5x negative.
Negative 1 over 5. Not x, just negative 1 over 5. You just take the number, not the x. Okay? That's your slope. Now, if the question says you, that your it's parallel. If it says parallel, your slope will remain exactly the same. Your slope will not change. Okay? If it says perpendicular, what you're gonna do is you're gonna flip and change the sign. So what does it become? You tell me.
5 over negative 1.
And change the sign, I said?
Oh. 5 over 1.
Just positive 5 over 1, right? Any doubt so far, Kat?
No.
Okay. So now you know the slope and you know the point. Okay? You know the slope and you know the point. What you're going to do is you're going to put in this equation. Y minus y1 is equal to mx minus x1. You're going to put in this equation. This is your x1, y1. This is your point x1, y1, and that's your slope. So I'm going to consider the question said perpendicular. I assume the question says perpendicular. I'm going to put, what's my y1?
y1 would be 7.
And what's your slope?
5.
Okay, x minus, what's your x1?
4.
Okay. Now, if the question says you that they want the answer in point slope form, this is point slope form. Okay. If they say they want the answer in point slope, your answer is done here. But if they say they need the answer in slope intercept form, that means you need y on one side, everything else on the other side. I don't need this minus 7, I have to take it that side. But I need to simplify this bracket first. Multiply this 5 inside, it becomes 5x minus 20, and then you have y minus 7. I just need y, so I'm gonna add 7 both sides. I get y is equal to 5x minus 13. That's my answer.
Okay. Maybe I can go. I think I got it wrong and I didn't finish the whole homework. I'm gonna check if that was the right answer that you just gave me.
Yeah,
Okay.
just try this one, or if it's parallel, you have to do it, just put the slope different. In case of parallel, you will put the slope different and then solve.
Okay.
Yeah. Any other question, Kat?
I'm checking the homework right now because I had trouble on like
Yeah,
one extra.
just take your time. I'm here only. Take your time, check. I'll help Jose till that time, okay?
Quick question with the division problem that you gave me.
Yes.
So you do one, so you do A on top, right? Because you would do A squared minus 1, and then you would
Okay,
multiply A by it.
Okay.
So that would
wait,
get
wait.
you.
Jose, first of all, did you put this in standard form?
Yeah, it would be A3 plus 9A2 minus 5.
What about the degree 1? There's no degree 1. So you have to add degree 1 yourself too.
Oh, we have to add the 1?
Yeah, so you get 0 a to the power of 1.
Or 8.
Negative 5. Right?
Yeah.
Okay, let's divide.
I forgot that you have to add those, sorry.
It's okay. If you don't add, you will figure it out yourself. When you're doing the question, you'll see you did something weird and you'll figure it out yourself. And you're dividing this with a square negative 1. Okay? What is the first term I write on the top here?
Wouldn't it just be A?
Yes, perfect. So what do you get here? What should I write here?
So you would write minus A3, well, A squared plus 1A?
Plus 1a, yes. See, if you don't write this 0a, you will be like, where will I write this 1a? Because you have to write a underneath a, right?
Yeah. See, that's where I was getting confused because I didn't know where to put it.
Yeah, that's the problem. That's why I say you have to write all of them. If you don't write that one, you'll be like confused at where would I write this a?
So then I would just bring down the 9 squared and do I bring down the A2 or just the A squared?
A. Yes, you have to simplify. If you have written here, you have to simplify.
All right, so now I would just find something that multiplies for that.
Yes, so what's your next? What thing I'm going to write on the top? Again, repeat the steps.
Wouldn't it be 9A? Wait, no. Just 9?
Yes. Because you divide the first term with the first term. So 9a squared divided by a squared will be just 9. So what do you get next?
So then that would get you minus 9 squared plus, wait. And then you change the signs, right?
Yes. So it becomes negative 9.
So then it'd be plus 9?
No, it would be, see, if you multiply 9 with a square, it's positive 9a square, right? I wrote it negative 9a square.
Okay, but for the number next to it, would it be plus 9 or would I not?
Positive 9, yes. Because you change the sign, right?
Yeah.
Okay. Now this cancels. I get this a down and I get here is, what is negative 5 plus 9?
That's 4.
4. Note, now if you do the step, a divided by a to the power of square, right? What do you get? A to the power of negative 1.
Would it? Oh, because you subtract, right?
Yeah. But you cannot have negative exponents. So that is, your answer is here. That's it. You cannot have negative exponents in the top quotient. So you're done here.
So my answer would just be A plus 9?
No, it would be a plus 9. Since answer would be a plus 9 only if your remainder is 0. But your remainder is not 0 here.
Okay.
So you're going to write a plus 9 plus a plus 4 over a square minus 1. Did you get it, Jose?
Yeah, so that's what I would put in online if we were to get a question line, because I would just put a plus 9 plus a plus 4 over a squared minus 1.
Yes. You want to do one more problem or you got this?
Yeah, give me one more.
One more? Okay, so you are going to give me let me pick up top one. Okay. So you're going to divide x, just a second, cat, okay? X plus 6x to the power of 4 minus 4 minus 3x square. You're going to divide this thing with 1 plus 2x square. Okay, you do this and I'll help you. Cat, yes.
Okay, so the question was, with an equation of the line containing the given point and parallel to the given line, express your answer in the form y equals mx plus b.
Exactly.
So my first step, originally, I solved the y equals mx plus b. I solved x plus 5y equals 8, and I got y equals negative 1 over 5x plus 8 over 5.
Yes.
That's what we got when we first did it, right?
Yes.
In the other one.
Yes.
Okay. Then I use that to plug it into the y minus y1 equals m parentheses x minus x1.
So what did you
I-
use your m now?
What?
What did you use your m now? M, since it was parallel.
I used negative 1 over 5.
Perfect. It's exactly the same. Yes.
Okay, so I did that, and I got y minus 7 equals negative 1 over 5 parentheses x minus 4.
Yes.
And I solved that out, right? So I solved it out, and I got y equals negative 1 over 5 x plus 11 over 6.
Why 11 over 6?
11 over 6 because I got,
I'm getting 39 over 5.
how are you getting that? Because that was the answer and I don't understand how
See
you
here.
got that.
So you are in 4 over 5. Did you get 4 over 5 when you opened? What is negative 1 over 5 times negative 4?
Times 4 over 1 equals negative 4 over 5.
Positive, because there are two negatives, right? This also has a negative, this also has a negative.
Okay, so 4 out of 5.
Yeah, 4 out of 5. You got 4 out of 5. Now what you're doing is you're adding 7 on both sides, right? I add 7. What is 4 over 5 plus 7?
That would be 7, 8, 9, 10, 11. 11 over 6.
See here. What's it? Here. Cat, see here. I need to add. What's my base here?
1.
I need to make the common base. How do I make it?
Putting them both with a denominator of 5.
Yeah, so this already has a 5 denominator, right? This does not have a 5 denominator. I multiply this also 5. I have to multiply the numerator also with 5. So what does it become? 4 over 5 plus, what is 5 times 7? 7 times 5?
35.
Yeah, 35 over 5. And what is 4 over 5 plus 35 over 5?
Okay, I think I get it now. Equals negative 1 over 5x plus 30. Okay, can we do one more problem that I also did bad on?
Yeah.
Can you just show me the problem real quick for my division one? Sorry.
Oh, here. Yeah. You tell me, Kat. What's the problem?
It is find an equation of the line containing the pair of points. Write your answer in slope-intercept form. 4, 5 and 12, 8.
12, 8. Okay, you got this thing, right? How do you find the slope? So I know I need y minus y1. This is my equation, right? X minus x1, right?
Yeah.
I know my point. I can take my point as anything I want. I take my x1, y1 as 4, 5. I put here 5. I put here 4, right? What I don't have is the slope. I need to find the slope. How do you find the slope when 2 points are given?
You solve it.
How? Which form? What's the formula for the slope when I have 2 points?
When you have 2, you would do y1 minus y2.
Yes, y2 minus y1 over x2 minus x1.
Oh, okay.
Find that thing and put in the formula.
x1 minus x2 equals.
Try doing that problem, yeah. And Jose, are you getting it?
I'm just a little confused because of the 1 in the equation, how it's 1 plus 2x squared that I'm dividing by.
Now let's
so
see. Let's see here.
Would I just move it to negative? Would I just move it over? Like, does it not really matter?
Let's see. First, you tell me inside. Let's see. Did you write the inside one in standard form?
Yeah, it would be 6x
4
with exponent of 4, power 4,
yeah,
plus 0 squared
x3
minus
3.
Oh, yeah, 3 minus.
Yeah.
And then minus 3x 2 to the power plus x minus 4.
Okay, perfect. Now you have to write this also in standard form.
Oh, okay, that makes more sense. So it would be 2x plus 1.
2x square
Oh yeah, 2x squared plus 1.
No. Is it in standard 2x squared? Then comes 0x plus 1. I mean, you don't have to write 0x in this case, but yes. 2x squared plus 1. Okay?
So we have to add the 0x if there's...
You don't have to add it here. You don't have to add here. No.
Okay.
Okay. So what's my first thing I'm going to write on the top?
On top, first thing would be 3.
I understand it now. I don't need any more help. I'm just gonna.
Yeah, sure, Kat. Okay, thanks, Kat. Did you
It would-
understand the division part, Kat?
I'm gonna. I kind of understood it, so I'm just gonna work it out. And if I need help, I'll just email you.
Sure, perfect. Okay, sure. Thanks, Kat. Take care.
So
Bye.
you'd multiply by 3x squared.
Okay, yeah, perfect. What do you get?
So then that would get you 6x to the 4, and then it would get you plus 3x squared.
Okay. What's my next step? Change
To,
signs.
to combine like terms.
No, change signs.
Oh, okay. So it would be the opposite. So I would do minus 6 and minus 3.
Yes. What happens? What is 6x4 minus 6x4?
That cancels out.
Cancels out. Okay. What about negative 3x squared, negative 3x squared?
Wouldn't that be negative 6x squared?
Perfect. You don't have to worry about 3x cube. That was something, if you got it, then you would have written underneath x cube.
Oh, okay. So I don't have to worry about that
You
right
don't
now?
have to worry about that. Let's get the next term down, which is positive x. So what's my...
So then,
Yeah. But I'm going to write it here.
wouldn't it be negative, just 3 or negative 3?
Negative 3. You divide, you'll get negative 3, right?
Yeah, because negative 3 times 2x power would get you negative 6x to the power of 2.
And negative 3 times 1 will give me?
Negative 3.
And then I have to change signs. What do I get?
So the 6's would cancel out, and then you would you'd pull down the x, right?
Yeah, pull down
Or
the
do you
x.
just leave?
Yeah, pull
Yeah,
down
you
x.
pull that down, and then you get plus 1.
Oh, negative 1, negative
Oh,
1.
oh yeah, negative 1.
Now here, see, this is x square, this is x, right?
Yeah.
You divide them, you're going to get a negative exponent, right?
Yes.
So that means this is your answer. So your answer will be 3x square minus 3. Then you write the remainder on the top and 2x square plus 1 at the bottom.
So if we can't break it down any further, we just always answer it with the acting like it's dividing.
Yes.
Basically, like
Yes.
whatever the top was and whatever the remainder was divided by the whatever was being divided by.
Yes.
All right. I think I get this now more.
You got this? No, you got it. You did it yourself. So you got it. Now this one.
All right. Thank you.
Yeah, you're welcome. You got everything else, Jose?
Yeah. Yeah.
Okay. Perfect. Okay, thanks, Jose. See you on Wednesday.
See you on Wednesday.